Right. I see it here.
Let's see. Yeah, there you go.
Yeah, great.
All right. So let's see. I guess I'll go ahead and begin.
Okay.
So, predicates and quantified statements to touchstone. Stand you both forth now. Stroke your chins and swear by your beards that I am a knave. Celia. By our beards, if we had them, thou art. Touchstone. By my knavery, if I had it, then I were. But if you swear by that that is not, you are not forsworn. William Shakespeare, as you like it. It's hilarious. Let's see. This section continues the discussion of predicates and quantified statements begun in section 3.1. It contains the rules for negation or for negating quantified statements, an exploration of the relation among for all there exists, and or, an introduction to the concept of vacuous truth of universal statements, examples of variants of universal conditional statements, and an extension of the meaning of necessary, sufficient, and only if to quantified statements. Okay, that sounds like a pretty fun chapter. Let's
Yeah.
see here. Um, is it rules for negating quantified statements? Like a
Yeah.
quantified being for all and there exists?
Yeah. Yeah, exactly.
Huh. So the negation of for all would be um, not every, right?
Yeah. Yeah, exactly. Um, yeah, not every, and then that would translate to saying like there is something that isn't like that.
Right. There is something that's not. Interesting. And then for there exists, it'd be all things are not, right?
Yeah. Yeah, exactly. So it's kind of like it is not the case that for all becomes there exists something that is not. So like
Right,
yeah, negative or negation of a universal quantifier is like an existential followed by a negation, and
right.
then it's the other way around. Negation for the other one, negation of an existential quantifier is like a universal followed by a negation.
Interesting. And then what about this and or? Let's see. An exploration of the relation among um for all there exists and or. I guess like just like combining and or into the quantifier mix.
Yeah, yeah, I guess that's what it would be. I guess there are a lot of things that could be referring to, but I guess yeah, something about like universal statements with the quantifiers and the conjunction and disjunction.
Interesting. Like either all x or some y, or maybe either all x or some x. Um,
Yeah, something like that. It could also be something like um all cats or well or like let's see all animals are either vertebrates or invertebrates. So that's like for all x, if it's an
oh,
animal, then it's a or I guess we can say for all x in the set of animals, x is a vertebrate or x is an invertebrate.
right,
But that's not equivalent to saying either all animals are invertebrates or all animals are vertebrates.
right,
So yeah, that means that like for all x, p of x or q of x is not equivalent to for all x p of x or for all x q of x. They're probably going
right.
to talk about that, I think.
Interesting. Huh. I guess for the existential quantifier, it'd be like there exists, or would it be like for some x, either p of x or q of x?
Yeah, and I think that maybe would be equivalent, or would it be? Or no? Um, I guess maybe that would be equivalent to there exists an x such that p of x, or there exists an x such that q of x. Like,
Right.
because that's like, um, like either some animal is a vertebrate or an invertebrate. Therefore, some animal is an invertebrate or some animal is a vertebrate. I guess that technically follows. And then if it's true that some animal is a vertebrate or some animal is an invertebrate, then it does follow that some animal is a vertebrate or an invertebrate. So maybe it does work with disjunction and existential and disjunction. Like you can split it up like that.
Yeah. I
There
think
exists an X. Yeah.
in terms of a truth table, it probably would be equivalent. It does seem like the meaning's a little different. Like if I mean to say that some particular x, for example, um, makes it true that either p of x or q of x, if that's what I mean to express, like that particular x makes it true that either p of x or q of x, perhaps that would be a different idea than saying there exists some p of x or there exists some q of x. They like might hit the same truth table, but it looks like you're trying to draw attention to two different aspects of the truth. Like in the second case, I guess you're trying to draw attention to the fact that somewhere in the universe, um, either p of x or q of x. And then in the other case, unless I'm mistaken, um, if you say
Well,
for all x, there exists an x such that either p of x or q of x, maybe you're like drawing attention to whatever that some x is, but maybe that's wrong. Maybe when people say the existential quantifier, um, like there exists some x, they don't mean to draw attention to whatever x that turns out to be.
yeah. Well, I guess it's open to interpretation. I mean, I do see how like someone could be doing that. Like there could be slight nuances to what they're emphasizing, or like
Right,
kind of the way they're expressing it, depending on which way they're formulating it. Um, yeah, it's kind of like either saying there's something that has one of these properties, or there's something with
right,
this property, or something with that property. So it is like they're saying something different, but the two things that they're saying happen to be equivalent.
right,
Um, but yeah, I guess yeah, two statements with equivalent meanings, I guess could have like subtle differences in what they're drawing attention to or how they're expressing something. Yeah,
right.
so I do agree with that.
Yeah, I think we may have hit that concept before back in the saying something negatively or positively, but it has the same meaning.
Yeah, yeah, exactly.
The vacuous truth of universal statements.
Yeah, I think what they're referring to there is like if you say like for all x, I'm in some set p of x, and that set is the empty set, then the statement's going to be vacuously true. Because like if you say um yeah, for all x in the empty set, x is a unicorn. Well, that's true because there isn't anything in the empty set that isn't a unicorn.
Right.
Yeah, so that's kind of a cool thing because then you can say like everything in the empty set has every property.
So why wouldn't that be true for the existential quantifier? Or why did they just mention vacuous truth of the universal quantifier?
Because I guess if you did the same thing with the existential, then you'd be saying like there exists an x in the empty set such that p of x, but that would be false because there doesn't exist an x in the empty set
Huh.
because there isn't anything in the empty set.
Right.
Yeah, so it would be hard to find like a statement with an existential quantifier that's vacuously true.
Right. Interesting. So okay. I guess the existential quantifier has more differences than to the universal than I thought. Like it also implies there exists. Like
Yeah,
I thought the universal quantifier also implied that there exists at least one, but that isn't the case, I suppose.
yeah, and that's kind of a difference from math language and like ordinary English. Because like if someone says like um all um
Right.
all animals are vertebrates or invertebrates, like they're saying all things of a certain kind are like this, they're usually implying that there are in fact things of that kind.
Right.
Yeah. Yeah, so I think that yeah, like someone wouldn't say in real life um or um like you wouldn't think or yeah, I guess yeah, someone I guess people can also say like all unicorns have one horn even though unicorns don't exist. Um
Well, even if
but I guess
they, yeah, they're implying the fictional unicorns that we know of, right?
yeah, yeah, so they're kind of like thinking about kind of like a concept or like a fantasy world like because like
Right. The
in
fantasy
linguistics people
universe.
talk about yeah like in linguistics people say that like people when they're making statements they might intend for those statements to be like evaluated relative to some world which might be a
Right.
fictional world. Yeah, and then the fictional world they have in mind unicorns do exist.
Right. And then, hmm. I guess I thought also anything you can do at the universal, you can do at the existential, or like that if you could pull that vacuously true trick with the universal quantifier, you could with the existential one. But I guess
Yeah,
the existential one actually does match up with how it's used in real life, in the sense that
yeah,
it does imply at least one. Like that's its
yeah,
whole purpose, really. So,
yeah, yeah, exactly.
interesting. I guess you could use the universal followed by a not, since that would be equivalent to the no, the existential followed by a not to create a vacuously true statement, since that should be equivalent to the universal statement, right? So if you say all unicorns um, have two horns, that would be true when you evaluate it um, relative to the world that doesn't have unicorns. Or like if you're talking about the empty set, you say all x for all x q of x. That would also be true. So I guess you could say wait, so you could say for some x it's not q of x?
uh I guess
That
yeah
would still be
for
false, right?
yeah uh well, let me see. So you're negating universal, so you have like it is not the case that for all x q of x, and that's equivalent to there exists an x such that not q of x.
Oh,
Um, so if the if you had the one you gave,
oh, okay,
all
okay.
unicorns have two horns, then the negation of that is there is some unicorn that doesn't have two horns. But the negation of that's going to be false because the original statement was vacuously true.
Exactly. So they are still equivalent. So what would be the equivalent of a universal statement in the form of an existential statement?
Uh, oh yeah, so we can one thing we can do is like well, we know if we had the negation of the universal statements, like it is not the case that for all we would have there exists x that is an x that is not. Um, then so that's what the negation of the universal will be equivalent to. And then if we want to get back what the universal will be equivalent to, we can negate again. Because if you double negate something, you get
Right.
back to the thing itself. So then if we negate there exists an x such that not, we end up with there does not exist an x such that not. So for all x, p of x is equivalent to it is not the case that there exists an x such that not p of x. Or in other words, like all cats
Interesting.
are mammals is equivalent to there is no cat that isn't a mammal. Yeah, so like in the case of the unicorns, like it's vacuously true that all unicorns have two horns. If we're supposing that like the set of unicorns is an empty set, then the corresponding existential would be like uh
It's not the
it is
case that some unicorn doesn't have two horns.
yeah,
It's not the case. It's not the case that some unicorn doesn't have two horns. Well, I
yeah,
think intuitively I know that that's the equivalent to the universal statement. I think I've done that several times before, saying a universal statement and then saying the equivalent existential statement, which is like there's a not and then the universe there's a not and then the existential statement and then another not. So
yeah,
now in terms of the vacuously true, so it's not the case that there exists a unicorn that doesn't have two horns. But
yeah.
the weird
Well, and
thing
then
about that, oh, go ahead. This seems like vacuously true statements are already fishy, but then like the equivalent existential statement is even more fishy because you
yeah,
could very easily make the claim that for all unicorns, um, one has three horns, or for all unicorns, they all have three horns, and it would also be true. So there would be a contradiction in our two existential statements because the existential statement, which is not the case, maybe it wouldn't be a contradiction though.
yeah,
it it's not the case that there exists a unicorn that doesn't have two horns.
yeah. So then you're saying like yeah, it doesn't exist. So like if you had like all unicorns have two horns versus all unicorns don't have two horns, those would be both be vacuously true, and then you'd end up with equivalently, it is not the case that there is a unicorn that has two horns, and it is not the case that there is a unicorn that doesn't have two horns, and both of those would be true because like yeah, which is kind of unusual, but technically not contradictory, because like there's nothing that has the there's no uni or no unicorn has the property and no unicorn or there exists no unicorn that has the property, and there exists no unicorn that doesn't have the property, because there exists no unicorns at all in general. Period.
There exists no unicorn that doesn't have the property.
Yeah, yeah, and there also exists no unicorn that has the property.
Interesting.
Yeah, because like since there aren't any unicorns at all in general, like there aren't any unicorns that have two horns, and there also aren't any unicorns that don't have two horns.
Right. I think the issue that my brain was dealing with is assuming that if there are no unicorns, then I guess there are unicorns that don't have the property. But like,
Yeah,
yeah, putting that under the microscope, obviously it's more true that if there are no unicorns, then there are no unicorns that have the property, and there are no unicorns that don't have the property.
yeah, yeah, exactly. Yeah, there is kind of like mind bending. Yeah, because like yeah, a lot of the math language uh, doesn't have like the implications that people would have when they just say it and say these sorts of things in ordinary conversation.
Right.
Yeah, because yeah, I do agree. Like if someone were to say like just in conversation like not no unicorns have there's no unicorn that has two horns, they are kind of suggesting that there are unicorns in general.
Right.
Yeah,
Interesting.
yeah, but I guess not so in the math language.
Yeah. Okay. I guess the takeaway is in the math language, if someone were to say there are no unicorns, um, such that P of X or such that whatever Q of X, it still leaves open the possibility that there are no unicorns in general.
Yeah, yeah, exactly.
Right. In ordinary language, adding on such that P of X or Q of X is what's the word I'm looking for? Unnecessary, eh, and therefore like what's the word? Misleading. It's like an improper use of language. Well, no, it's technically I don't know if there is like a I don't think it's an improper use of language. It's like grammatically correct, but yeah, just in terms of social programming, you wouldn't add anything else to the rest of that sentence because that would imply because that would be inefficient. The only way that that could be efficient is if you mean to imply that there are some x such that some other fact is true.
Yeah. Yeah, exactly. Yeah, and there's like an area of philosophy that's just like about that, or linguistics that's about that kind of thing. Like this philosopher named Grice, Grice, came up with like these maxims of conversation, like rules for conversation that like they are supposed to follow and that people are expected to follow, and that
Right.
influence the interpretations of what people say. Because like yeah, like you said, it's kind of like superfluous information. Like if there are no unicorns, then why would you say specifically that there are no unicorns that have two horns when you could just say
Right.
there are no unicorns at all? Yeah,
Interesting.
it's like in this room there aren't any fairies that are green.
Right.
Yeah, you're kind of like you wouldn't say that if you didn't think there were fairies in the room at all.
Right. I like the fact that I guess this book is asking us to exercise um awareness of this nuance because I guess that would result in more perfect logic if you're highly aware of this nuance, you have a much stronger command of the language. I think it's in beginner territory to really get tripped up by a nuance like this.
Yeah.
Hmm.
Yeah, yeah, definitely.
Yeah.
Yeah, yeah, it's good for yeah, like we can kind of think about language and logic very precisely. Because I guess yeah, even in ordinary language, like if someone says uh, there's no unicorn that has two horns, they technically don't like that statement technically doesn't strictly imply that there are unicorns. It kind of just like suggests it, like you would expect someone to say it only if they thought there were unicorns, but
Yeah.
like strictly speaking, it doesn't imply that. Um,
Right.
yeah,
Huh. Yeah. I'm pretty sure I saw one or two movies where the protagonist managed to outsmart the villain or something in some kind of riddle like situation by doing a trick like this.
yeah,
Hmm.
yeah,
Okay.
yeah. I can see that.
Yeah. So remind me of what inspires you to read so much philosophy. Is it just some pure enjoyment or some dream that you have?
Yeah, well, I guess I just enjoy it. I like kind of reasoning about things and kind of uh, thinking about things more deeply. And yeah, I just hope to have like some kind of like um perspective on things that I didn't have before.
Yeah.
See things in different ways. Yeah, yeah, I just kind of enjoy that kind of aspect of it.
See.
Yeah, and I guess in terms of some aspects of philosophy could be helpful for kind of like reflecting on your life and stuff like that. And also some of them are just kind of fun puzzles.
Yeah. Hmm. Well, let's see.
Yeah. Yeah, and let's see the last thing we got here, extension of the
There's
meaning of
also
necessary is sufficient.
examples of variants of universal conditional statements.
Oh, I forgot that one. Oh, I missed that one. Yeah. Um uh yeah, I don't know what they I guess like universal conditional like for all x, if p of x then q of x. Yeah, I'm not sure
Variants.
what variants they have in mind, but maybe like involving and or and stuff like that. Yeah, I'm not sure which ones they're talking about.
Hmm. For all x, if p of x then q of x. And then I guess a conditional with universal statements within it would just be considered a conditional, right?
Yeah,
Okay.
yeah, and then maybe a universal conditional has like a universal quantifier in front of the whole conditional.
A universal conditional.
I think it's like for all x, and then if p of x then q of x is kind of within the scope of the for all x. Like the for all x applies to the whole conditional.
Yeah, I can see that.
Yeah, but yeah, I'm not sure what the variance of that would be. So maybe they're just kind of like combining those with different connectives or something like that. But I guess
Right.
yeah, we'll see. It'll be interesting.
Huh. Yeah. The universal just kind of restricts, I guess, the scope of the conditional. So I'm not sure what the variation of that would be. Let's see. An extension of the meaning of necessary is sufficient and only if to quantified statements. Um,
Yeah, I guess. Um,
what's a quick review of what these mean? Necessary, and then there's sufficient.
yeah, I think it's like um, so like informally, like P is a necessary condition for Q. If like P has to be true in order for Q to be true. Like um, like um, in order for it to be true that this animal is a cat, the animal must be a vertebrate. So like kind of being a vertebrate is sort of necessary for being a cat.
Right.
Doesn't guarantee being a cat, but it's necessary. And then informally, sufficient means like um, it guarantees the thing that it's sufficient for. So like being a feline is sufficient for being a cat, or something like that.
Or
Or
being
like
a cat is sufficient for being a feline?
yeah, yeah, I still go both ways in that case. In that case, it's like a definition or like two synonyms. I guess like um being equal to 4, 6, or 8 is sufficient for being even, I guess. Because
Yeah,
if something is equal to 4, 6, or 8, then it's guaranteed to be even. It's not necessary to be one of those to be even, but it's sufficient.
true.
But I guess then, but then like we can think of those in terms of conditionals as well. Like if we're saying like P is sufficient for Q, that means if P then Q, the truth of P guarantees the truth of Q in some sense. Because like if that conditional is true, then whatever P is true, Q's got to be true. Um, but then like P is necessary for Q would be if Q then P, because like whenever Q is true, P's got to be true just by the truth table
Right.
of the conditional. And that's kind of what necessary means. Like it's something whenever Q is true, P's got to be true. So that means that P is necessary for Q. Um,
Right.
yeah, and then only if so like P only if Q is another way of saying if P then Q. Because like
Right.
one way to think about it is like once again looking at the truth table of a conditional, if P then Q, that means that um, in the truth table, if you've got P is true, and for the conditional to be true, Q's got to also be true. So, in other words, P is true only if Q is true. So, P only if Q is another way of saying if P then Q. And it's also another way of saying um, Q is necessary for P.
Right.
Yeah, and I guess maybe they're kind of looking in the context of quantified statements at what like some examples of like one statement being necessary for another to be true or something like that.
In the context of quantified statements.
Yeah. Yeah, so maybe like just like some examples of quantified statements where one is necessary for the other or sufficient for the other or something like that.
Hmm. I wonder if these are all strictly conditionals or if they can be used in other ways. I can imagine a universal conditional statement like for all x, p of x only if q of x, or for all x, p of x is a necessary condition for q of x, like for all cats. No, no. You'd say for all animals, um, being a vertebrate is a necessary condition for being a cat.
Yeah. Yeah, you could say yeah, you could say that. But I guess like that could also be defined in terms of conditionals. Like for all animals X, um if
Right.
X is a cat, then X is a vertebrate. Or if X is not a vertebrate, X is not a cat. That'll be an equivalent way of doing it.
Okay.
Yeah, because I think the book and when they define necessary, they also say like P is a necessary condition for Q means if not Q, then not P.
Right.
Or no, it means sorry, P is a necessary condition for Q means if not P, then not Q.
Right.
Or equivalently, if Q, then P.
Right.
Yeah, so I guess yeah, you can have like you can have statements where like you say as part of the statement, this is a necessary condition for this, but then like in the logic that could still be translated using conditionals. But I guess there are always like other ways to express conditionals, like you can express them without using the arrow. Like you could say instead of if P then Q, P or not Q, for example.
Huh.
Or no, Q or not P. Um, so like you could also express them without using a conditional, like P is a sufficient condition for Q. That means if P then Q, so it's also like equivalent to saying Q or not P.
Right. Okay, fair enough. So I suspect in this chapter we'll just kind of exercise uh, the limits of different expressions, of different forms of expression. Um, hmm.
Yeah.
Okay, I guess that's comforting. Like, let's see here. For some reason, I thought of negating quantified statements as being almost like a new piece of logic as opposed to. But I guess the whole point of this chapter is to just exercise various expressions of the quantified statement some more. I think so.
Yeah.
Okay. So let's see. Negations of quantified statements. Consider the statement, all mathematicians wear glasses. Many people would say that its negation is, no mathematicians wear glasses. But if even one mathematician does not wear glasses, then the sweeping statement that all mathematicians wear glasses is false. So a correct negation is, there is at least one mathematician who does not wear glasses. The general form of the negation of a universal statement follows immediately from the definitions of negation and of the truth values for universal and existential statements. I would like to see the negation's truth value. So, the negation of a statement of the form, for all x in D, Q of x, is logically equivalent to a statement of the form, some x in D such that not Q of x. Symbolically, it's not the case that for all x in D, Q of x is equal to some x in D such that not Q of x. Okay. Thus, the negation of a universal statement, all are, is logically equivalent to an existential statement, some are not, or there's at least one that is not. Note that when we speak of logical equivalence for quantified statements, we mean that the statements always have identical truth values no matter what predicates are substituted for the predicate symbols and no matter what sets are used for the domains of the predicate variables. Okay. Now consider the statement, some snowflakes are the same. What is a negation? I guess all snowflakes are not the same. For this statement to be false means that not a single snowflake is the same as any other. In other words, no snowflakes are the same. Interesting. I guess all snowflakes are not the same is not the same as saying no snowflakes are the same.
I think it is another way of saying it. Yeah, like all of them are not like this is equivalent to saying none of them are like this.
But
So
you
so
could
yeah, I
all,
think like, most of
depends on the emphasis because you could say all of them are not like this, but some of them are.
oh yeah, I guess yeah, all of them are not like this. You could mean not all of them, as opposed to every single one isn't.
Right.
Yeah. Oh yeah, I see. Yeah, so I guess there's that kind of an ambiguity in English. Yeah.
Saying all of them are not like this, as opposed to saying all of them are different.
Yeah.
Interesting.
Yeah. Yeah, maybe that's why they said it that way to avoid that ambiguity.
Like specifically because of that ambiguity.
Yeah.
The general form for the negation of an existential statement follows immediately from the definitions of negation and the truth values for existential universal statements. The negation of an existential statement. The negation of a statement of the form some x and d such that q of x is logically equivalent to a statement of the form all x and d such that not q of x. Or for all x and d, not q of x. Symbolically, it's not the case that some x's in d such that q of x, some x in d such as q of x, is equivalent to for all x in d, not q of x. Thus, the negation of an existential statement, some are, is logically equivalent to a universal statement, none are, or all are not. So, example, negating quantified statements. Write a formal negation or write formal negations for the following statements. All primes p such that, or well, for all primes p, p is odd. And the other one is there exists a triangle T such that the sum of the angles of T equals 100. Okay.
Yeah. Yeah, so then we can use the general principle like negating a universal statement. It is not the case that for all. Then we can think about like what is the general structure of the negation of that using an existential.
For all, um, so the
So
negation
like
of
not
this. Mm-hmm.
so like it is not the case for all of that for all of them they're like that means there exists one that isn't like that. So like not for all is equivalent to there exists some such that it is not.
Interesting.
So in other words, like for both of them, when you're negating them, you end up with something equivalent to the reverse the other quantifier with a negation coming after it. So not for all gives you there exists some that is not. It is not the case that there exists gives you for all of them not.
Uh,
So it's kind of like you flip the quantifier and you put the negation after it.
right.
So for all primes p, p is odd, we'll have like it is not the case that for all primes p, p is odd. So then we can re-express that as an existential statement. If not all of them are odd, then there's got to be one that isn't odd. So we're going to have like, it is not the case that for all primes p, p is odd is equivalent to there exists a prime p such that p is not odd.
Yeah.
Yeah, and then the next one we'll do like the reverse of that. We have there exists a triangle T such that the sum of the angles of T equals 200 degrees, and we want to negate that. It is not the case that there exists a triangle T such that the sum of the angles equals 200 degrees. So to negate that, we're going to have like something equivalent to a universal statement. So
Let's
it's
see.
not the case that there exists one that's like that. So all of them are not like that.
Right.
Not negative existential or negation of an existential is a universal with a followed by a negation. So we'll have for all triangles T, the sum of the angles of T does not equal 200 degrees.
Right. I guess it would be redundant to say for all triangles T, no triangles have angles that sum up to 200 degrees because you already said for all triangles. So you don't have to
Yeah,
say no triangles a second time.
yeah, yeah, because saying no triangles are like this is like saying for all triangles they're not like this. Yeah.
Right.
Yeah, exactly. So the universal quantifier would be contained within the no there.
Right.
Yeah. Yeah, but I like the point that they made that like some people think that like would naturally think that the negation of a universal statement is like turning the all into no. Like all cats are mammals. People might
Right.
think the negation of that. Yeah, because people can naturally think that the negation is no cats are mammals. But that's actually not the negation because like and one way of thinking about it is like what if someone said all cats are gray. To prove that, you don't need to show that all cats are not gray. You just need to find one counterexample. So you just need to show that there exists some cat that isn't gray. Um, yeah, so like the negation is kind of what you need to show in order to disprove something.
Hmm. That's intuitive, although it's less intuitive that the negation is not the like complete opposite.
Yeah,
Or I guess it is the complete opposite, but you would think that the complete opposite would be just, well, I want to say the symmetric opposite, but actually, I guess the um existential with a not after it would also be the symmetric opposite. So
yeah,
the issue is like assuming, wow, I'm having an image here, but let's see. I think when people think of opposites, there might be some kind of image in their head, like the opposite of the day is the night. The opposite of yes is no. The opposite of white is black, and the opposite of all is none.
yeah,
But at least according to logic, the opposite of all is not all. I guess,
yeah, exactly.
yeah. I guess the opposite of day might be not day.
Yeah,
The opposite of true is not true, which just happens to be equivalent to false. So you would also say false is the opposite of true, but through logical equivalence. But the opposite of true, the direct opposite of true, without the need of, I guess, logical equivalence, would be not true.
yeah, yeah. And I guess like, I guess like either way of defining opposite is fine. But yeah, I guess the way logic does it, they don't think in terms of like, yeah, the way we think about opposites normally. They just think like statements and their negations. But there isn't really a term for like all of them versus none of them. but actually Aristotle did like come up with two different terms. I think they're translated like contrary versus contradictory. Like the statements, all cats are mammals, and there is some cat that isn't a mammal. Those would be like contradictories. And
Right.
all cats are mammals. Yeah, so that's like kind of what we have in logic, like a statement and its negation. But then he also had a term for like all cats are mammals versus no cats are mammals, and he would call those like contraries or something like that. So he actually like came up with terms for both of those situations in his logic. But I guess in modern logic, they don't really have a term for the relationship between like all of them versus none of them.
Contrary seems to imply a contradiction too, though, right?
Yeah. Yeah, and I guess they're like I guess a statement and its contrary do still contradict each other. But because like it can't be true that or well, um I guess well, all cats are mammals versus no cats are mammals. Both of those could be true if there are no cats at all. But
What's the
otherwise
definition
there
of a contrary?
oh, a contrary would be like um or in terms of universal statements like two a pair of contraries would be like for all x p of x, and then the contrary would be for all x not p of x.
Hmm. Okay.
Yeah, but that one's I think maybe specific to Aristotle's logic, like that using a specific term for that. Although maybe people do it in modern logic sometimes too. But he did like have different terms for like taking the universal statement and its negation versus the universal statement and what intuitively looks like its opposite.
Yeah.
Yeah, yeah. So it's cool to see kind of those distinctions and like how the logic is different from ordinary language.
Interesting. So, in a universe between including -5 and 5, um, you might say, oh, well, I guess the opposite of 5 would be not 5. So there exists an opposite in that universe. There exists an opposite of 5 in that universe. Since every other number would be considered an opposite of 5, at the very least, every other number is not 5.
Yeah, yeah. Like if you have the statements like um, x equals 5, and if you want to say the opposite of that statement is x doesn't equal 5, then yeah, that would be equivalent to saying x equals -5 in that universe, and -5 happens to be what we would intuitively think of as the opposite.
It might also be considered the contrary, depending on how we set things up. But, like, so if there only existed 5 in this universe, my first question is, does an opposite exist?
Yeah, I guess there wouldn't be an opposite. I guess because I mean you can define opposite in many ways, but I guess the opposite like would if it's like a the thing that's like as or like that we intuitively think of as the opposite, like the reverse of whatever property 5 has in some sense, then you get -5, and that doesn't exist. Or if you think of the opposite as just something that isn't negative, that isn't 5, then that doesn't exist either. So as the opposite wouldn't exist.
Hmm. Yeah.
Yeah, and I guess in math we do have the term opposite applied to -5. Like -5 is the opposite of 5, where opposite means like it's on the other side of 0, like equally far from 0, but on the other side.
Right, this equal distance from 0. So
Yeah, same absolute value.
that's how you could also consider -5 would be the contrary, since, like, 5 might be equal to a universal statement like let's see, Hmm.
Like a universal statement involving five, like in a universe that only has five in it.
Um, Maybe that would be simpler. I was thinking of a universe that has from -5 to 5.
Yeah,
The so the statement is like in terms of contraries, the structure of contraries is like a pair of contraries would be one is for all x p of x, and the other one is for all x not p of x.
yeah,
So for -5 to be the contrary of 5 as opposed to simply a contradiction, um, and that's what I'm trying to put the words together to express. Oh,
yeah. Well, well, yeah. I guess you can define them in many ways. I guess if you define contraries to be just pairs of statements, then technically five, like the number five itself, wouldn't have a contrary, but like a statement involving five could.
I guess
Like,
this 5 on a number line could be 1, 2, 3, 4, and 5, or 1 and 2 and 3 and 4 and 5, such that -5 could be not 1, not 2, not 3, not 4, and not 5. So if you were to define 5 as a conjunction of the positive numbers, and you define negativity as the negation of positive numbers, then -5 could be defined as a conjunction of negative numbers or a conjunction of negations of positive numbers. And a contrary would be the negation of all um, I guess assertments in the original universal statement, right?
yeah.
So
Oh yeah, yeah. That's really cool. Yeah, yeah. I like that. That's really fascinating. Yeah, yeah. You could do that, and yeah, that could be the contrary. Like you negate all of them, and have a conjunction of all of them negated, and then the contradictory could be like a disjunction of all of them negated.
ah,
Um, because like if you want to negate like one and two and three and four and five, then by De Morgan's law, the negation of that would be not one or not two,
right.
etc. Yeah,
Interesting. Interesting. Hmm.
yeah. That's really cool.
So not 5. If 5 has to be the conjunction of the positive numbers, then not 5, like at the very least, could be, I guess, either the conjunction of some but not all of the positive numbers, or the conjunction of some but not all of the positive numbers and at least one negative number. Most likely, whichever positive number is missing from the conjunction. Like
Yeah,
most, so yeah, interesting.
yeah, yeah, yeah. That's really cool to think about. Yeah, I
Hmm.
like that. Yeah, but I guess in mathematical logic, I guess they don't end up caring about contraries. But they're interesting
Contraries.
to think about.
Yeah, it's a nice concept to have at the very least at the beginner level. Like it helps refute the fallacy of thinking the contrary is the
Yeah, the
negation.
contradictory. Yeah, the negation. Yeah,
Right.
yeah,
Hmm.
yeah. It's a useful term to have.
Yeah. That P is
Yeah.
not B. Okay, let's see.
Yeah. And they got another example there.
Really? More negations. Rewrite the following statement formally, then write formal and informal negations. So, no politicians are honest. They want us to rewrite the statement formally, then write formal and informal negations. So, first
Yeah.
to write it formally, I guess this would be for all politicians X. For all politicians X, it's not the case that H of X, or for all politicians X, X is not honest.
Yeah. Yeah. Exactly.
All right, let's see.
Yeah. And then to negate that, we'll have an existential.
Negate this formally, yeah, an existential. So we'd say, well, let's see.
Yeah. So we'll have like there exists a politician X such that it's going to be what you need to show to prove that it's to disprove no politicians are honest.
So there exists a politician that is honest.
Yeah.
Or
Yeah. Exactly.
there exists a
Yeah.
politician
So here.
X such that X is honest.
Yeah. Yeah. Exactly. So it's here. Here we're like. So we had a universal statement, and then to negate it, we did existential followed by a negation. But in this case, we have like there exists a politician X such as that X is not honest. So double negating gives you equivalently what you said. There's a politician that is honest.
So say that once more with the double negation.
Oh yeah. So like in the original statement, we had like for all politicians, X is not honest. And then the rule is like negating a universal statement, you get an existential followed by the negation of whatever was inside the universal. Um, so like we're gonna have there exists a politician X such that it is not the case that X is not honest, and it is not the case that X is not honest is just equivalent to X is honest. So those would be kind of like the full steps. So you have like a double negation because in general, if you want it like all of them are like this is equivalent to there is one or sorry, not all of them are like this is equivalent to there is one of them that isn't like this. So here, all of them are not honest is equivalent to there is one of them that isn't not honest, or there is one of them that is honest.
There isn't one that is not honest. Oh, okay. Would be the equivalent. And then you just negate that one to get there is one that is honest, right?
Yeah.
So when you negate first of all, a negative existential quantifier, the one that we had was there was a not in front of the existential as well as a not in front of the predicate.
Yeah, or well, in this case, we had like, well, so we had this for all politicians, X is not honest. We negate that, and then in general, negating a universal gives us just an existential followed by a negation, like with a negation inside of it, in the scope of the existential. So we don't have a negation in front of the existential quantifier, but we do have one after it. So it's like for all politicians, X is not honest. Then that gives us there exists some politician X such that it is not the case that x is not honest.
Right.
Um, yeah, and then we have x is honest, but that middle step is kind of can be done intuitively. Um, yeah, so you kind of got right away that it was there exists a politician x such that x is honest. But then like we also have kind of implicitly that intermediate step is going on as well.
I like that. So the equivalent, the existential, the universal statement's equivalence is an existential with a not before the predicate, right?
Yeah,
And
yeah.
I don't know if that was revealed to us. Was that ever said explicitly?
Uh, that was well, I guess that's technically what they had in the first box on page 109. They kind of didn't put it in exactly those words, but yeah, it's kind of like they gave us the rule kind of like
Ah,
the negation of for all x in D q of x is logically equivalent to there exists an x in D such that not q of x. So that's kind of another way of putting it. We can say the negation of a universal statement is an existential statement with a corresponding existential statement with um, with a negation before the predicate.
and then they did so the equivalent of an existential also happens to be a universal with a negation in front of its predicate.
Yeah, yeah, exactly. So in each case, if you want to find something equivalent, or you're going to get something equivalent to the negation if you just flip the quantifier and put a negation before the predicate.
So there exists some cat that is black would be the equivalent of saying for all cats, um
Or well, the negation of there exists some cat that is black would be equivalent to this form.
oh wait, so let me go back up. So the negation of for all x and d q of x is for some x and d not q of x. But
Yeah,
back in our example, were we saying that the equivalent of, let's see, no politicians are honest, or for all politicians,
yeah. So for
none.
all politicians, x is not honest. So the negation of that is going to be equivalent to the corresponding existentially quantified statement where you put a negation before the predicate. Um, so you would have there exists a politician X such that it is not the case that X is not honest.
That's the negation. Okay, okay. So what is the equivalent? Like, what's the equivalent existential statement to a universal state? So if you say for all x, p of x, is that equal to, that's equal to, it's not the case that for some x, not p of x.
Yeah, exactly. Yeah,
Okay.
yeah. Because the negation of it would have been equivalent to there is some X such that not P of X. But yeah, the equivalent to the original statement, not its negation, yeah, would be yeah, like you said, there is not the case that there exists an X such that not P of X. As like it's like if you say everything is like this, or all of these things are like this, it's equivalent to saying there isn't any of these things that isn't like that. There isn't one of these things that isn't like this.
Mm-hmm.
Um, yeah. So like for all x is like it is not the case that there exists an x such that not.
That makes sense.
Yeah. And then similarly for existentials, like an existentially quantified statement would be equivalent to like one that starts out with it is not the case that for all x not. So like there exists an x such that p of x is equivalent to it is not the case that for all x not p of x. Because like if you're saying that there is one of them that's like this, that's like saying not all of them are not like this.
Right. Okay, that makes perfect intuitive sense.
Right. Yeah, and then in the example, I guess we just got one more step. So we have the
Mm.
formal negation, but now we just gotta turn it into an informal version, like using just words.
Um, s- so
So like instead
negation of
of there
politicians
exists a
process.
politician X such that X is honest,
Some
how would that be said?
politicians
Like,
are honest.
yeah, yeah, exactly. Yeah,
Interesting. That's cool. It's like they're trying to educate us by teaching us the formal logic and making sure it's like all the way encoded into the depths of our minds so that we can express it informally from the perspective of formal logic as opposed to just trying to like it may be ineffective to try and teach us this without starting from a formal logic standpoint.
yeah, yeah. The symbols are definitely very useful and kind of yeah that kind of formal language and framework. Yeah, yeah. If you're kind of just using English and or like kind of or any language and like natural language, then
You won't
yeah
have the precise
uh,
logic.
yeah, yeah, I gotta have that precise logic because otherwise, like, just ordinary language has all sorts of implications and kind of ambiguities that the formal
Right.
language doesn't.
And then also, if you only taught the formal language but not the informal language, maybe the person that is the resulting person may not be fully built.
Yeah,
Like
yeah, like it
it,
wouldn't really teach you, like, it wouldn't help you with your reasoning to the same extent.
right.
Yeah, I actually had a class that only taught the formal language and didn't really talk about how it applies to ordinary language and reasoning.
Right.
Yeah,
It,
yeah, but it is good to look at both of them together.
yeah. I suspect it would still be better to look at if you had to choose one, if you could only choose one, the formal language, since I think that that's the precursor. Um, there's a chance that you might like stumble upon the connection between the formal language and your everyday life experience. Whereas if you're just to learn the informal logic, I think the only way that it would help is if you intuitively already had a grasp of the formal logic.
Yeah, yeah, and that's kind of less likely that you kind of have a grasp of that without kind of explicitly looking at it.
Right. So, interesting.
Yeah.
Huh. Okay. It's just kind of like, I don't know. To me, I find it like kind of weird, but in a good way to imagine a world where people are educated in the formal logic, but they communicate with each other through the informal logic. And so both layers are at play at once when they're in conversation.
Yeah. Yeah, that would be good. Yeah, they could maybe yeah, have an understanding that when they say things that sound like just ordinary language, they mean them in kind of a precise sense.
Right.
Yeah, like yeah, yeah, if they're kind of if they have the formal logic in the background, then like things that could be ambiguous normally wouldn't be ambiguous.
Right.
Yeah, and that does happen in math. Like people will sometimes or oftentimes say things in informal language, like without necessarily using the existential quantifier and the symbols. but because that background is there, it's understood what they mean precisely.
Yeah. Okay, let's see.
Yeah,
Another way to avoid error when taking negations of statements that are given in informal language is to ask yourself, what exactly would it mean for the given statement to be false? What statement, if true, would be equivalent to saying that the given statement is false? So, okay, that's one way to avoid error when taking negations of statements that are given
yeah,
in informal language. And I think
yeah,
that's what you're saying. Like, what makes the universal false would be the existential with the negation on the predicate.
yeah, yeah, exactly. Like in the statement, we had like all cats are gray. To disprove that, you don't need to show that all cats are not gray. You just got to show that there's some cat that isn't gray.
Hmm. And to disprove it, um, I guess implies the negation. And
Yeah.
I suppose I might need to look at the truth table because I didn't. It's not intuitive to me that disproving it would also be the negation of it. I suppose, like in terms of a truth table, what would be the definition of the negation?
Oh well, the negation. So like the negation is true if the statement is false, and it's false if the statement is true. So I guess like if you're disproving a statement, then you're showing that it's false. And if the statement is false, then its negation is true. So when you're disproving a statement, you're also proving its negation. Because like
Thus,
if you disprove p, that means you're showing that p is false. And if p is false, then not p is true. So disproving p is the same as proving not p.
and what bothers me about the truth table is for it to be a negation, it has to be the opposite truth value in every case, right?
Yeah,
Otherwise, it would be called something else, but not the negation.
yeah,
I don't even think I've ever seen the truth value of a universal statement. So if I said for all x, for all x, p of x, I wonder what that truth table even looks like. I guess you would have an x that can either be true or false.
yeah. Well, I guess technically people don't like do truth tables for statements like that. I guess they just do it for propositional logic. Because like, um, for all x, p of x, whether that's true or not depends on the universe. It depends on what is the domain from which you're taking the x's, and like, is it the case that all of those x's really do have that property? So like for some universes, for all x p of x will be true, and then for other universes it'll be false. So you'd have to like make a table with every possible universe, but there are infinitely many possible universes. So like you couldn't make a truth table for it, but you could say like what it means for it to be true, and it means that like for any x in whatever the universe is, um, p of x is true.
So
Like for example, if your universe were like the set of 2, 4, and 6, and you said for all x, x is even, um, then it would be true for that universe because the universe just consists of 2, 4, and 6, and each of those is in fact even. It does have the property. Um, but if the universe consisted of the set of 1, 3, and 4, then for all x, x is even would be false because there are things in the universe that aren't even.
so you could make a truth table so long as you have a defined universe.
Yeah, yeah. I guess um, you could. I guess Although I guess if you have to define universe, then the truth table would just have like what is the truth value for that universe.
Mhm.
It'll be either it'll be either true for that universe or false for that universe.
Okay. Throughout the book, it seems like the examples seem to default to real life as the universe, but there are times where they will specify the universe, whether it be like the Tarski's world or um,
Yeah, they'll specify. Yeah, it could be represented as a Tarski world, or it'll be some set that the
right,
value
a
is taking
set.
the variable is taking values from. Yeah, and I guess technically they could also specify like all of the like the p's and the q's and everything as predicate symbols. Like they can specify like which sets of things do and don't have those properties. Or I guess yeah, they could specify like sometimes like a specifying a universe, or especially specifying like a full model means like specifying the universe and also specifying like which things have the properties. And then they'll give you all the information you need to determine the truth values of statements for that universe. So like
Huh.
you could have like the universe is the set D in them, and then they'll also give you like a set of things that have property P and the set of things that have property Q, and that'll give you like the information you need. So that's kind of like an abstract way of thinking about it, but um,
Huh.
you would be given like that full information would be in the background when you're determining the truth value of a statement relative to some universe,
True. I think that,
relative to a model.
yeah, that would probably be the more complete way to do it. You'd have the domain of things, and then there's also, I don't know what the simple way of
Yeah,
saying it is, but like the mapping of what objects has what properties.
yeah, yeah, exactly. Yeah, and then some properties apply to like pairs of things, like something being less than something else, then you would have a set of ordered pairs. That'll tell
Right.
you what are the things where the first one is less than the second. Um, yeah, and then also I guess like the whole thing would be called a model, and then in the model you might also have like what the constant symbols represent, like because sometimes there will be constant symbols like letters that represent some specific value, and then the model will also specify what they represent, like what thing in the universe. Um, but yeah, the model will kind of specify everything you need to evaluate the truth value of a statement.
Right. What is the constant used for? You said it represented like why would you need a
Yeah,
constant?
they'll like represent specific objects in the universe. So like you could use uh, B to represent like a specific cat or something. Um, yeah, so the constant symbols, yeah, symbols that represent a specific thing in the universe, and then the model would specify what they represent specifically.
Huh.
Yeah, so the model kind of yeah it tells you the domain of, for the variables, and then it also tells you like kind of what has what property and what represents what, and those kinds of things.
See. Now let's see. I see 2D in the chat. Are you still at work, 2D? Cause if not, maybe we'll try and teach you something. Still at work. Are you like on break or how are you communicating with me right now? Let's see. To actually teach you something, we would need like 10 minutes of your undivided attention. So it's not it's not that hard, but it's not easy enough that you could just learn it with 25% of your mind.
Yeah, we can try it out.
Let's see.
Yeah, like these examples here under still more negations would be useful for illustrating the concept. They're starting out just with the informal versions.
Hmm. So let's see, Whitaker, if we're gonna teach this, you'd probably want to teach the foundation, which is like what is the universal and the existential uh statement, right? And you'd be safest to assume no knowledge of variables. I mean, you could try and teach it from that perspective, but it might take you too much time. So you'd want to, I guess, we'd have to rely on informal language just to kind of um, warm up the mind to the concepts.
Yeah, yeah, we can do that. Yeah, and luckily the example, the next one is just doing it informally. So yeah, we can provide motivation that way, like just with the informal concepts. Yeah, so like, well, like the first idea is like that a universal statement is a statement saying like all things of a certain kind are like this, like all cats are mammals, all vertebrates are mammals, um, all books are cool, or not all of them, but like a lot of, but all books are written, uh, all yeah, that kind of thing.
I have a question.
Yeah.
Like, if you don't add the predicate, would it still be a universal statement? So if you just say all books, I guess it wouldn't be a complete statement without the predicate. You just say all cats.
Yeah, yeah, that wouldn't be a complete statement. Yeah, like
What would it
yeah,
be
it wouldn't be like a
called?
full sentence.
Would that be called a universal?
I guess it would be like a universally quantified variable or something like that.
Huh.
It'll be represented as like for all x or for all x and d or something like that.
Yeah.
Yeah, yeah, but yeah, you're gonna have like all something or something, like
Every
yeah, all dogs are mammals. Yeah, those kinds of things. Those would be universal statements.
every
Um,
cat is a mammal.
yeah, yeah, exactly. So you could also say every instead of all. Yeah,
Each human is mortal.
yeah, yeah, exactly. Yeah, so all, every, each, all of those would be introducing a universal statement.
Yeah. I'm just trying to think of what tools you'd want to give someone who you're educating on the definition of a universal statement. As they walk around life, like what tools do they need? I guess I assume they would need to know these different examples because that's probably what they're gonna get hit by on a day-to-day basis. But yeah,
Yeah, yeah, yeah, and I guess yeah, kind of the examples kind of illustrate the concept. Like yeah, all cats are mammals. Um, all uh, planets are orbiting a star. All um, yeah, like all something are something. Those would all be universal statements. All universal statements are of this form.
yeah,
Um, yeah, so like that's what a universal statement is, and then an existential statement is saying that like something has some characteristic or property, like some cat is gray, or there is a cat that is gray.
Right. At
Those
least
kinds of
one cat
things.
is gray.
Yeah, exactly. Yeah. So you're saying that there's like something of this kind that has the property or the characteristic.
Now it's
Yeah.
time for a nice little quiz before we move on. So, 2D, if you're still there, give me an example of a universal quantified statement. And then I'll ask for an example of a existentially quantified statement. Now, do we call these universal quantified statements or universally quantified?
It's universally quantified.
All of the houses
Yeah.
are burning. Yes, that's good. Now try and give a existentially quantified statement. And you sure it would be existentially quantified and not existential quantified statement?
I think existentially quantified because like existentially would be like an adverb modifying the adjective quantified.
Interesting. As opposed to a noun and its name is existential quantified statement. Like there are
Yeah.
quantified statements, some of them are existential and some of them are universal. But
Oh yeah, I guess you could have that too. But I guess the way I've heard it is generally like existentially quantified.
yeah, I mean, universal quantified statement seems to be a misleading phrase anyway. Some houses are burning. Correct.
Yeah. Yeah, exactly.
Interesting.
Yeah, so you got it. You're on fire today.
Hilarious. Perhaps you have an affinity for this.
Yeah. Yeah, it seems like you're fired up about it. Um,
Wow.
yeah. So yeah, you got what these kinds of statements are, and then the concept for this lesson here is like how do you negate them? Where negating a statement means like if a statement is represented as P, the negation is not P. So like um yeah, it is not the case that if you say like it is not the case that all the houses are burning, you'd be negating the statement all of the houses are burning.
Right.
Um, or this cat is gray. This cat is not gray. It is not the case that this cat is gray. Would be the negation. Um, so yeah, if you wanted to negate all of the houses are burning, you could just say it is not the case that all of the houses are burning. But another way of expressing that would be to say um, some house is not burning. Because like if not all of them are burning, then there must be some house that isn't burning. Not all of them are like this, then one of them isn't. Like um, if it is not the case that all cats are gray, that means that there is a cat that isn't gray. Um, yeah, so in general, if you want to negate a universally quantified statement, the negation is going to be the statement saying, or like if the quantified statement is all of these things are like this, the negation will be uh, not, or there is one that isn't like this.
So you
Um,
gave two lessons there, or 2 points. I'm gonna make sure she has them both. But first, I wonder, can you guess the 2 points that you gave that I saw?
I guess one of them is kind of just what a negation is.
Uh huh.
Um, and then there's also like specifically what is a way of expressing the negation of a universally quantified statement.
As an existential one. Yeah, you gave a
Yeah.
point of how do you negate a universal statement like directly, I guess. And then you also showed how to express the negation of a universal statement as an existential statement.
Yeah.
I'd be pleased if she could do both. So just it would be nice if someone just generally can understand the negation of universal statement first of all, like as the foundation, and then once I'm sure that they get that, it's time to move on to expressing it as an existential statement.
Yeah. Yeah. Sounds good.
So then, TD, let's say your universal statement is all of the houses are burning. what would the negation of that statement be? If you were able to follow Whitacre's logic, then you know there's at least two ways you can express the negation of a universal statement. None of the houses are burning. You know, like the book warned us about thinking that that would be the negation of the universal statement, but it's not.
Yeah. Yeah, one way of thinking about it, like, cause yeah, I do see it. It does kind of seem like none of the houses are burning would be the negation of all of the houses are burning. Um, but the idea of negation is like, it is not the case that all of the houses are burning. What does that mean? So in other words, like, if you wanted to, like, if someone said all of the houses are burning and you wanted to prove them wrong, what would you need to show? You wouldn't need to show that none of them are burning. You just need to find one and show that it is. You need to show that one of them isn't burning. Because if you show that one of them isn't burning, then you disprove the person who said that all of them were burning. So the negation of a universally quantified statements, like all of them are like this, is going to be there is one of them that isn't like this. So like if someone says all cats are gray and you want to disprove that, you got to show there is a cat that is not gray. You just need to show one counterexample, and then that'll disprove the universal statement. Because like formally, the negation of a statement is like it is not the case that that statement. So like it is not the case that all cats are gray. What that another way of expressing that is saying there is a cat that isn't gray. Um, but yeah, maybe the most helpful way of thinking about it is like, what would you need to show to prove someone wrong if they said it? That's the negation. So to prove someone wrong when they say all of them are like this, you show that um, there's one of them that isn't like this.
So try again. For all of the houses are burning. What would be the negation of all of the houses are burning? Hmm.
Yeah, yeah, exactly. One of them isn't burning.
One of them isn't burning. Yep,
Yeah,
exactly.
exactly right.
Interesting. I guess teaching this lesson to someone who just hopped in, the word negation, the definition, like the full meaning of the word, seems to be the takeaway that I see so far.
Yeah, yeah, kind of the concept of negation, and then like, yeah, like what is it? What's a way of expressing the negation of a universally quantified statement?
True, true.
Yeah, yeah, great job.
So let's see. I don't know if you explained the negation of a existential statement. Maybe we ought to let her like try and guess, cause you
Yeah,
know,
yeah, that's good. Yeah, so maybe, yeah, see if you can like, what do you think the negation of some houses are burning would be?
so you have to think, how would you disprove the statement of some houses are burning. The word some,
Yeah,
yes,
well,
that's a part of it.
yeah. And like, yeah, if you want to show that it's that not that some you want to disprove that some of them are burning, yeah, do need to show something about all of them. And like, what do you need to show about all of them? Like all of the houses are.
I can tell she already knows what some means, but I imagine like in informal language, some implies more than one, but in logic, some actually means at least one.
Yeah, yeah, that's an important point. Yeah, it's like someone said some houses are burning, meaning like at least one of the houses is burning, and you want to prove them wrong. And you got that to prove them wrong, you need to show something about all of the houses. And what would that be? Like all of the houses. Uh, oh yeah, well, so not quite. You're almost getting there. Like, so some houses are burning. Um, the negation is going to be like it is not the case that some houses are burning. Um, and you were right earlier that like if it is not the case that some houses are burning, then something has got to be true about all houses. Um, and because like if you show that at least one of them isn't burning, that doesn't disprove that some of them are burning. Because maybe maybe there's one that isn't burning and others are. Um, so like yeah, I think I mean someone said that some houses are burning, or at least one house is burning. How would you prove them wrong? You wouldn't be proving them wrong yet if you just showed that one of them isn't burning. What would you need to show?
Hmm. I'm still thinking about the word some, but
Yeah,
so
this one is kind of tricky if you haven't seen it before.
so
Yeah.
basically, like if the statement is at least one house is burning, how would you disprove that statement? If you say, well, at least one is not burning, that actually doesn't disprove the guy who says at least one is burning.
Yeah, because like what if you imagine that there are 10 houses, and someone says um, yeah, at least one is burning.
To
Yeah,
disprove
like you
him,
could point to,
oh yeah, I
yeah,
mean, go ahead. Like, yeah, to disprove him, you couldn't say, well, at least one's not burning. That doesn't disprove a statement.
yeah, because there could be one that's burning and then one that's not burning.
Yes. I think you were closer before when you uttered the word all, But you didn't give a complete sentence.
Yeah, yeah, exactly.
Precisely. That would
Yeah, because
be
someone said,
the negation of an existential statement. What were you gonna say?
yeah, because like, yeah, like if someone said like some houses are burning, meaning at least one house is burning, and you could prove them wrong by showing that all of the houses aren't burning. Yeah, because
Hmm.
then, yeah, that means there isn't one that's burning. Yeah, yeah. So to sum up, with a sum statement or like an existentially quantified statement, something is like this. The negation of that is going to be like everything isn't like this. Um, so like uh, some cat is gray. The negation of that is all cats are not gray. Equivalently, there is a cat that is gray. The negation is all cats are not gray. Yeah. So
Right.
like in summary, like universal statement, all things are like this. The negation of that is there is something that isn't like this. Um, an existential statement would be like something is like this, or there is a thing that is like this. The negation of that is going to be everything is not like this, or everything like of the right kinds, like houses or whatever it is not like this. Yeah,
When I was saying
yeah, very well done.
that some is the same as at least one, yeah, I didn't mean to confuse you or throw you off. But like, this still bothers me. For example, we say someone, like we know that we have to say one after some because some doesn't seem to mean at least one. Or we say some say rather than, well, let's see. If I were to say, some say that coffee is a delicious drink.
Yeah,
Even if I only heard one person say it and I only mean to refer to that one person, it would seem like I'm being misleading.
yeah, yeah. I agree. Yeah, like you said, some kind of suggests more than one. Yeah,
But that's utterly irrelevant to what we're talking about here. It's just my own
yeah,
fascination.
yeah. Just a lot of ambiguity in English that isn't there in logic. Yeah, yeah. And by the way, I have to head out in a couple minutes.
Oh
But
yeah. Let's see. So where do we get?
we got to right before still more negations.
So should we do still more negations and then, or do you want to end now?
Yeah, we could quickly do still more negations.
Okay, let's see. So write informal negations for the following statements. Informal negations. So all computer programs are finite. I think the informal negation would be some computer programs are not finite.
Yeah,
The next one is some computer hackers are over 40. All computer hackers are under 40 would be the negation.
yeah,
The number 1357 is divisible by some number between 1 and 37. So let's see here. The number 1357 is divisible by no number between 1 and 37.
yeah,
By no integer. Interesting. If we had more time, those would have been perfect to test the audience with.
yeah,
In this paragraph says informal negations of many universal statements can be constructed simply by inserting the word not or the words do not at an appropriate place. However, the resulting statements may be ambiguous. For example, negation of all mathematicians wear glasses is all mathematicians do not wear glasses. I think I made this point once. The problem is that this sentence has two meanings. With the proper verbal stress on the word not, it could be interpreted as the logical negation. What? You say that all mathematicians wear glasses? Nonsense. All mathematicians do not wear glasses. Interesting. On the other hand, stated in a flat tone of voice, it would mean that all mathematicians are not wearers, or all mathematicians are non-wearers of glasses. That is, not a single mathematician wears glasses. So they wanted us to try it. All mathematicians do not wear glasses. Interesting. This is a much stronger statement than the logical negation. It implies a negation, but is not equivalent to it. Wow, I'm glad they even threw in that point. Very thorough.
Yeah.
Now, so okay. Thank you for coming, 2T. I think that we will end the stream here and probably have another one Thursday. Are you free Thursday, Whiticker?
I think so. I'll let you know when I know for sure, but I think I should be.
Okay. If you know early Wednesday, we could also just do it Wednesday. Encore, indeed.
I'm glad you enjoyed it.
So yeah. Well, all right. Let me end the stream.
Yeah, great job, Judy. Thanks for coming.
Later.